still looking at the Geometry TEK 7.5c. It says, and we're on page 5. The bases of two similar triangular prisms shown below are equilateral triangles. What is the value of an x? What is the value of x? An edge length of the larger prism in centimeters. Oh, this one. Okay. All right, so triangular prism does say they're equilateral. Equilateral means all side lengths are the same. All sides are equal, which is where we get the equilateral from. Now that's just of the triangle, right? Because it says the bases. And because it's a triangular prism, we know that these are my bases. Don't get confused and think, but it's sitting on a rectangle, which is the bottom. Okay, that's not true. These triangles are my bases. So that just means that this measures 7, this measures 7, this is 2.8, this is 2.8, okay, because they're equilaterals. Let's see. We have similar figures. We need to think proportion. So I'll do large ratio equal to the small shaped ratio. And then I guess I've got to do like, I could color code. We'll do that because that corresponds. That's the base of your triangles. Okay. And then you have, I'll use, I have red right here. Since I'm solving for x, I've got to find the side length that also corresponds to it, which is that guy. So let's do blue on top and red on bottom. So the large blue squiggly, okay, from the large blue squiggly is measuring 7. Then the red from the large is x. The blue squiggly from the small is 2.8. And the red squiggly from the small is 11.2. Okay. Yuck, these numbers are gross. Plus, it's an open-ended question. Okay, it's fine. We can do this. Do I see shortcuts? Not really, no. And I can't estimate, so I'm just going to have to multiply. 2.8 times x. Bring down your equal sign. 11.2 times 7. Remember, I can multiply as if they're whole numbers, and at the end, introduce my decimal back in. 7 times 2, and again, the reason I do that is so that I'm not forced to think I need to line up decimals, because if you lined up decimals, you'd have a lot of work to do. 7 times 2 is 14. 7 times 1 is 7 plus 1 is 8, and 7 times 1 is 7. So, the 112 becomes 11.2, and then the 7 is just plain, so that's 0. So I need one number after my decimal. So it's a 78.4. One-step equation now, and I'm dividing by 2.8. Remember, you always divide by the number that's in front of your variable. It's called the coefficient. Ooh, and listen, for you guys that hate to divide, you're going to be out of luck if you hate to divide here. That's the only way to do this one. 2.8. Top dog in the house. But remember, I need a whole number here. So that becomes 28. This becomes 784. I'm going to rewrite it. 784 and 28. Okay. Let's do this. 28 does not go into 7. 28 into 78. Let's see. That's almost 3 6. I'm going to say twice. 28 times 2. 16. 4 plus 1 is 56. Oh, I don't think it goes in another time. Does it? No. That'd be too many. So 56. Even if it did go in another time, I'd be able to realize after I subtracted. 8 minus 6, 2. 7 minus 5 is 2. So let's say this was 28 or 29 or 30 or more than 28. I would know that I needed to change that to a 3. But that's not the case. So move my move my number 4 down. Oh. And now 28 into 224. Okay, let's think. It can't be 10 times 9's probably too many. Let's try 8. Again, division is like a guessing game. You pick a number and you try it. 8 and 8 is 64. 16. And that's 22. Oh, yes. Perfect. Yay. So that ended up being not as painful as I thought it was going to be. And I ended up with a nice whole number answer of 28. Now, please, don't put the 28 over here. Remember, which I should have done, but when I moved my decimal here, it should have gone straight up into my answer, which means my decimal belongs there. The only place to put the whole number of 28 is here. And again, because it's positive, I don't have to bubble that in or put a plus, but I can if I want to. The only time they count off is if you have a negative number and they don't put in, if you don't put in that negative sign.